My pleasure.
No. Jacob said, where's the number? This is at the bottom of the page. He said, thanks, Ash.
All these pages were turned sideways. So I was
Daniel, why are they sideways?
they were printed sideways. Look, see?
Oh. Oh. Yeah.
Yeah. I'm thinking I was dumb.
Yeah, well, mine are at home on my desk, so we're gonna.
Wow, so irresponsible.
I literally went home and did no calculus for a week.
I did too.
What happened to that notebook you had that had like 3 pages?
Okay, here we go.
Your rocket notebook.
If you had to explain to someone how to find the derivative of a polynomial, what would we do? How do you do that?
Take the exponent, multiply it.
Find the coefficient.
Yeah.
Okay.
If it doesn't have. Yeah, that's basically it, honestly, because if it doesn't have.
By the coefficient, and then what else?
Lower the exponent by 1.
Okay.
Yep.
So are we just going backwards?
Yes.
So we're going to multiply by 3.
No, it's going to be like the coefficient times the exponent, right? And lower the coefficient.
Well, we just did the
Oh,
coefficient.
So
times
no,
the-
I'm saying opposite, or take the coefficient and multiply it by the exponent. That's going to
Well,
be lower
exponent times coefficient is the same as coefficient times exponent.
So yeah, but instead of doing this, you're doing this.
Commutative property. Go ahead.
So are we going to like delete 1 from the exponent and then multiply? Are we just going to do it from like do 2?
Delete 1. What do you mean delete 1 from the exponent?
Like take it down by like. Are we going to do 2 1 instead of 1 2? That's what I'm saying.
Yes.
Okay, so you would lower the exponent first and then.
No.
Oh, then what?
What's the opposite of lowering the exponent?
Raise that.
Raise.
Yes.
So you're doing 2.1.
So we're going to increase, because we got to do the opposite, antiderivative.
Oh, got it.
Increase exponent by 1. And then what?
And then divide.
Divide
Ew. Oh no.
the coefficient by the new exponent.
I was just joking. Thanks for joking. Are you serious? I literally hate division more than anything else.
Okay, so the antiderivative,
What's the purpose of this?
so that you can undo. You got to have inverses. Just like, plus the inverse is minus. Multiplication, the inverse is division. You've got to be able to undo.
And then we have
what you've
inverse.
done. This is the
Equations.
inverse derivative, which is the antiderivative. Okay, the antiderivative is this symbol. It looks like a S that's kind of pulled out.
A music note.
It does look like a music symbol.
So when you find the antiderivative, you're finding the function f of x, the function of which f of x is the first derivative. So, for example, it allows you to go back. If you were given the derivative, you can find out what you had to begin with.
So basically, I've been doing this already, just now.
Sure. So, however, if the antiderivative of f prime of x, this dx, allows you to know what you're taking the antiderivative with respect to. So, because sometimes you won't just have x. Sometimes you'll have an x and a y. Sometimes you'll have other letters. So it's just telling you, hey, we're taking the derivative with respect, or antiderivative, with respect to x.
So you found the derivative.
So does anybody see a problem here? For example, let's say we had,
You're getting the derivative times the derivative?
well, look, if we had the derivative, what is the derivative of 2x? 2. What is the derivative of 2x plus 4?
2.
Okay.
So if there's one that doesn't have an x,
It ain't gonna be there.
So if I asked you for the antiderivative of 2,
We would just say 2x.
well, it could have been, according to this, 2x or 2x plus 4.
Yeah, so how do we figure out?
So how do we fix that?
There's another equation.
Oh my
Here's how we fix that. The integral, that's a term, antiderivative, of f prime of x dx is f of x, so what you have to start with, plus Chuck.
Chow?
Chuck.
Chuck.
We call it Chuck.
His name is Chuck.
Chuck. It's the
That
constant
should be the sign.
integration is what it's called, but we call it Chuck.
I love
And you'll
it.
hear me often say, don't forget Chuck.
What is Chuck?
Exactly.
Constant.
Chuck could be 4,
Chucky.
could be 0, could be 275. It was a constant that we don't know.
So all our answers have the letter C.
Yes.
Man, this is making it too hard.
Oh my gosh.
Like, why do we have to include a serial killer baby doll in our problem?
I didn't say Chucky.
And then,
It feels like Chucky to us.
Yes.
To murder our
Okay,
brains.
well, let us call it Chucky.
His name is now Chucky.
Or it could be a creepy mouse. It
That's
could be a
so
serial
nice.
killer baby doll or a creepy mouse.
That would also murder me.
What
Yes.
mouse is named Chucky?
Chuck E. Cheese.
Oh, sorry.
When you think about it, that's
Chucky,
also
even a baby
terrifying.
Okay, so here we go.
I mean, even a baby doll.
We're taking the antiderivative of each one of these. So it's like you can spread out the antiderivative. You're taking the antiderivative of 3x squared plus the antiderivative of 2x plus the antiderivative of 3.
Oh, no, wait, I'm doing it right. I'm just not doing that.
Okay.
Okay, so what was the first step?
X to the 9.
Increase the exponent.
2x to the
Increase the exponent by
9.
1.
3.
So it's x cubed, and then we
Divide the coefficient by the exponent.
divide by the exponent.
I don't like this. Which is just going to be x to the cube.
Right.
X cubed. I'm fine.
So for the next one,
X to 2x to the negative 2.
What?
You raise the exponent, which would be 2.
Oh, you raise it. Hold on.
And then divide
What did you do?
by 2. I don't know.
she's trying to take the derivative.
She's speaking tongue.
Now this one is really x to the 0 here.
1.
So you add 1,
Uh-huh.
so that's x to the first, and you divide by that 1.
Yeah.
And don't forget
C.
Chucky.
Oh,
I thought we were calling it Chucky.
you don't have to find C?
No. Oh, hallelujah.
Oh, that's easy.
Okay, great. So now we have
So our final answer?
x cubed plus x squared plus 3x plus Chucky.
Plus Chucky.
Whatever. We did
That's
it.
not too hard
No.
I think.
until we get to the next page.
Until you decide to give me, cosine and sine.
Oh my goodness.
Well, that's on the next
Or
page.
pi over 2.
Okay, so for each one of these, we're dividing by x.
That kind of hurt.
Wynn's like, quit whining and just come on. So it's an integral x cubed divided by x is, I'll write it like this first.
Oh, we're gonna have to do ID.
The reverse
The reverse loading high minus high D.
Oh, no.
Oh, good.
Period. But what is the x going to do to us?
What is it gonna do to us? Well, it's similar to Chucky.
Chuck.
Oh, sorry, wrong movie. That was Psycho. Hang on. All right. So x cubed divided by x is what?
X squared.
Over X.
Yeah, because see, they're all divided by x.
So we first have to get rid of the x, and
We're just
then,
dividing by x. I'm writing it out, but yes.
and then we do the raise the exponent.
Yes.
Okay.
Now, you don't have to write it out this long each time. I'm just doing it so you'll have it in your notes.
2.
Yes. The next one is 2.
Negative 4 over x.
Dx. Plus negative 4. Let's go ahead and write it as an exponent.
To the x to the negative 1.
Okay.
Ooh, I did that.
Look at you.
So-
Oh, forgot the dx here.
So-
Yes, once we take the antiderivative, we will switch out. We haven't
Okay.
done that yet.
I thought we were doing.
No, we were just dividing by x. Now we take the antiderivative.
Okay, great.
It's x divided by 3.
3 to the x cubed.
Yes.
Whoa.
So we add 1 to the exponent and divide by that new number.
I thought that was gonna be easy.
2x
1 over
divided by 1.
2 over. Well, there's not an x.
Right?
Well, it got
Yeah,
raised.
where'd the
The
x
x
go?
exists.
So if there's
Yeah.
not an x, how
It's
did
x to the 0.
Mm-hmm.
What's
Because
the
remember,
derivative
x to the
of
0 is 1. So there is an x there.
It's like 1. It's an invisible x.
And it makes sense because when you take the derivative of 2x, what do you get?
2.
2. So if you take the antiderivative of 2, you should get 2x.
Yeah. Okay, great.
Okay, great. Now the next one.
4x
Well,
and
zero.
negative 2.
0.
You
Oh,
add.
0.
Yeah.
0.
So it's just negative
0.
Oh.
Yeah, guys, it's 0.
Okay.
4. Duh.
1.
So,
I didn't know there was a freaking x.
negative, what was it? Negative 4 x to the 0.
Over.
Over 0.
Oh.
Uh-oh.
Boo.
So that's going to be 1 over 0, which is just 0.
Do you remember?
Nope.
No.
You can't have 0 in the bottom, actually.
No.
Do you remember taking the derivative of 1 over x?
It's
No.
Lynn.
Yes, it's the natural log of x.
Lynn.
So for a problem that looks like this, when it's x to the negative 1
Is it
or over x, no, it's the natural log. So it's minus 4, the natural log of x, plus
Chucky.
Chucky.
Lynn and Chucky are friends.
This is a great equation.
Lynn,
I thought so.
my pen doesn't work. Oh!
That was not a cheer. Ashley was sad because she had to leave calculus.
Not because her pen died.
Yeah.
I definitely was more upset about the pen.
You were sad. It was like, no, no, no.